I'm Adam Thompson, the designer and developer of First Earth, and I'm going to show you what I've been working on lately. So I got business cards that I can hand out at meetups and stuff. I upgraded my video card so that I can do demos at more than like 15 frames per second. But when I upgraded the card, I built my own computer, and I put it in into the motherboard, and it wouldn't start up. And so I tried a few times, and I discovered that I didn't have enough power, and I had fried my motherboard by trying to put it in. So I had to buy a new power supply, and I had to buy a replacement motherboard. And but now it works. Here's the result of that. It's my work table there. But now I can show demos at a pretty good frame rate. So I will switch over to the game and start showing you what I've been working on as far as deer. So here's my Unity client, and I'm on a hill. So when I first turned on the testing server with deer, it started spawning deer constantly. And the problem is that there's so many zones. There's more than 400 zones just in the test server. And each zone was trying to spawn deer. It was very inefficient. So I had to upgrade that algorithm to be much more efficient. I did that, and I released another build, and it's much better. I talked about inverse kinematics in my last video, so I'm going to show you what I ended up doing with that. Let me turn down the details. So if we just look at this deer on the slope, I didn't actually use inverse kinematics because it was way too complicated for quadrupeds. Instead, you can see the deer just aligns itself with the slope. So, you know, unlike the player, which is standing straight, the deer is actually tilted with the slope. And it looks a little funny, but it basically works, and it's good enough for now. And you can see even the player doesn't actually have that. You can see how the player's feet are not totally aligned. And that I will use inverse kinematics for when I have time. Let me see what else I want to show you. Oh yeah, I wanted to tell you I did some crazy trigonometry. It's like I took trig in school, but I haven't used it in a decade. So I ended up having to sort of relearn the basics, because when the animal turns, like if I run over here, maybe this one will run away from me. He has to turn toward me, and then he has to turn away from me and run toward a point that's away from me. So that's all trig. I had to learn some equations and look up some stuff again. Still running away. Yeah, so learn some trig. Sometimes I wonder if I'm a terrible coder. Let me show you my, so here's actually some code. This is the Erlang code for the server. And you can see I've got a function here called distance. And it just, if you're a coder, this just looks really repetitive and dirty. Like, I'm not sure if this is necessarily the best way to write this function, but you know, it works. So what happens here is I can pass in a player and an object, or an object and a player, or an object or an object, or a player and a player, and it'll calculate the distance between them. And here's the actual algorithm. And then I've got another function here, get angle degrees between, and this will get the angle from 0 to 359 degrees between two players or objects. And then I also have get direction from degrees, which will get a direction vector, like x, y, z, or actually in this case just x and z, between two objects. And so that lets me turn deer. It lets me see which direction things are from each other, and calculate distances between things, and have things rotate the right direction. So that was a learning experience. Another thing I learned and worked on was spreading objects across multiple zones. So previously all my objects were in a single table, which was shared by all the zones. And so when you like clicked an object into a zone, it would query that table, and it would look for objects of the type that you had clicked in the zone that you had clicked in. But it was getting really slow as soon as I added deer, because deer are objects. Everything in the game is objects. That's not a player. And as soon as I added all these deer, suddenly there's like 40,000 deer, and all of those queries were really slow. And that was relevant for spawning deer too. So what I did was actually split out the database so that each zone server now has its own table, which means that when it's searching for an object in a zone, it only has to search among the objects in that zone. It doesn't have to search through other zones' objects now, which is what you would expect, and that's what it was designed for. So it was a pretty easy switch, but it really, really improved speed on the server. Another horrible thing, there was a major bug that I discovered on the server that I discovered when my testers were playing, and sometimes the server would crash. Just randomly, it seemed like. The server would crash while they were testing. And so here's what I discovered. So a long time ago, I implemented it so that as a player, you could cross a zone boundary, and it's totally invisible, and the zone transfers you. So what it does on the Erlang server, Proxima, is, so like here's a server line, you're here, you cross over, and the server says, the server on this side says, this player needs to transfer out. And so it says, I'm giving you this player. And this other server says, okay, I've got this player, I've saved it now in my database, you can delete it. And then the first server says, okay, I'm deleting it. And that's the transaction. And that's also how objects are transferred if you carry or if you drag an object across a zone boundary, that's what happens. So it's pretty seamless. But what I discovered was that in Erlang, the language I'm using, it's actually possible if the servers message each other at the exact same moment for them to get in what's called a deadlock while they're waiting for each other. So they're both like, so if you're sending, say, two players cross a zone boundary at the same time. So they both cross that boundary, and if those messages get sent at the same time, then the servers are each waiting for the other one to complete the transaction. So this server is saying, I'm trying to transfer this player, I'm waiting, and this one is doing the exact same thing, and they both can't receive each other's messages because they're still waiting for the one that they're sending. So it's a horrible deadlock, and it's really, I was afraid it was gonna be a major issue, a design issue in my server architecture. But I worked with it, and I ended up solving it by, rather than doing transfers through messages like that, now I do transfers on the database, and the database is able to handle, the database for Erlang is called Amnesia, M-N-E-S-I-A, and it's able to handle multiple processes sending messages at the same time, and it puts them in the correct order, and it does things one at a time. So I'm pretty pleased that I was able to solve that at all. Everything's a little harder in First Earth because of the huge world and having multiple zones. But having multiple zones allows us to have a seamless world where we could have as many, like unlimited players in a zone, in an area. You know, if I show you the game, you can, theoretically, we can put all of the players that are playing First Earth in one big area, and it theoretically would work. So that's the trade-off. The cost to that is it's pretty hard to work with cross-zone issues, but I've mostly solved all of that. Okay, we're almost done. My next work, what I'm going to work on today, and for the rest of this week, is property harvesting and survival. I'm going to get the basics of survival so that I'm not sure what I'm doing yet, but maybe you'll have to have water or you'll have a certain amount of energy where you can run around with. And then I'll get harvesting working so you'll be able to extract more than just bushes from the world. Right now, all you can do is bushes. We'll get some other harvestable stuff in there. And then property, I want it so that if you're working property, like you're producing harvested things on it or crafting things on a piece of property, you should be able to own that property. So we'll get property ownership. And I'm going to start getting that in some form, and that'll have to be based on you working the zone. So that's why I need harvesting sort of working and survival sort of working before I can implement property. That's it. Thanks for following First Earth.